Welcome back, viewers, to the program The Stellar Twin Voyagers. Today, I, Nova A239, will once again guide you through another adventure of the siblings as they strive to explore their colorful dreams. Let us together explore the eternal realms and fulfill dreams amidst the sea of stars. Prepare to be captivated by the wonders of the universe and stories full of hope that will inspire us all. After finishing lunch and taking a short break while sharing stories in Cosmo's room, Grandfather returned to the fields. I'm going to help Grandfather and Father in the fields first. We'll meet again later this afternoon, Aster said, adjusting Cosmo's blanket and patting his younger brother's head before quickly heading off to find Father and Grandfather in the fields. Father, Grandfather, I'm here. I'm ready to help, Aster said. Good, thank you. This batch is already dry enough, suitable for baling, Father said. Aster nodded and walked towards the stack of straw his father mentioned, then began baling as before. One by one, they completed the straw bales. While Aster shaped the bales, Father moved them onto the cart. Then Father drove the cart and unloaded them into the storage shed near the field, and soon returned to repeat the process for the remaining straw. Before they knew it, they finished all the straw they had worked on. Phew, this is the last of it for today. The rest here will be dry enough by tomorrow, so we'll continue then. Aster, once you're done with your bales, you can go shepherd the sheep and return home, Father said. All right, Father, Aster replied, then hurried to finish his task. After completing the baling, Aster bid farewell to Father and Grandfather and hurried towards their sheep pen, beginning to guide the sheep out to the pasture. Some mischievous sheep tried to stray from the flock multiple times. Aster continued to shake the bells on his shepherd's staff, guiding the sheep back to the flock. Working alone is quite challenging. If only Cosmo were here, it wouldn't be so overwhelming to watch over all these sheep, Aster muttered to himself while counting the grazing sheep to ensure none were missing. Once the sheep finished grazing and drinking water, Aster led them back to their pen and secured it. All right, job done for today, Aster said, running back home. Mother, I'm home, Aster said as he arrived at the door. Cosmo, why are you sitting at the dining table? Oh, Aster's back, come here, Aster, Cosmo called out. Welcome back, Mother greeted. Wait, I'll freshen up first, Aster said, washing his face, hands, and feet behind the house. Aster quickly returned. Shouldn't you be resting in your room? Why is Cosmo sitting here? Aster asked. Oh, about that, your younger brother has been whining. He didn't want to sleep, saying his fever has gone down and his cold has improved. He asked Mother to allow him to see you in the fields, but Mother was worried his flu might relapse. Instead of going to the fields, Mother invited Cosmo to bake cakes for the upcoming autumn festival together. Here, some are already baked. Aster, try one, Mother said. Oh, Cosmo, you're still stubborn even when you're sick. You should be resting more, Aster said, slightly annoyed. All right, Mother, I'll try it. Wow, Mother, this is so crispy, and is this chestnut? The aroma is irresistible, Aster exclaimed happily after tasting the cake his mother had baked. Yes, that's right, I'm still making the others. Actually, I'm not sure yet which cakes to make for the festival, so I'm trying out all the recipes I know and having Cosmo taste them to get his opinion on which one is the best. Since Aster is here now, why don't you give some suggestions too? There are still a few cakes left to bake, Mother said. Before long, Father and Grandfather also returned. We're back, Father said. Wow, what's all this hustle and bustle? Is Mother baking cakes? Cosmo rushed over to Father and Grandfather and offered each of them a piece of cake. Father, Grandfather, try this. How does it taste according to Grandfather and Father? Grandfather squatted down, patting his grandson's head and saying, Wow, have you recovered, Cosmo? You seem very energetic. Let Grandfather taste it. Really delicious. Your mother is truly #1 in cooking. Grandfather thinks there's no other woman in this village who can match her. Yes, Father is right. This cake is truly delicious, Father said. Mother blushed and said, Oh, you too, don't praise me like that. I'm just following the recipe, nothing special. Father and Grandfather laughed, then Father said, We'll go to the chicken coop first and we'll be back soon. Aster, help Mother and Cosmo here. All right, Father, don't take too long, Aster said. Of course, Father replied, then prepared to leave for the chicken coop with Grandfather. Your father and Grandfather came home early today, so I think I will start preparing dinner now. Can you help me transfer these cookies from the trays to the jars of prepared? Understand, Mother said. Sure, Mom, leave it to us, Cosmo replied enthusiastically. Slowly, they transferred the cookies one by one into the jars and sealed them. Aster touched Cosmo's forehead. Are you really feeling better? Cosmo replied, slightly annoyed, Stop treating me like a kid, brother. I'm only a year younger than you. I've been fine for a while now. You look a bit pale today, are you okay? Aster nodded while transferring cookies. Of course, I'm perfectly fine after helping Father and Grandfather. You don't need to worry about that. Shortly after, Mother started bringing out the dishes for dinner one by one. Aster, once you're done transferring the cookies with Cosmo, please call Father and Grandfather for dinner. They often lose track of time, Mother said. All right, Mom, Aster replied, I'm finished. I'll go call Father and Grandfather now. Aster hurried outside, but it turned out that Father and Grandfather had already returned home. Seeing them, Aster said, Grandfather, Father, Mother has finished cooking dinner. Let's have dinner together. Grandfather smiled and said, Right, let's have dinner together. I'm starting to get a bit hungry. They all took their seats at the dining table and began to eat while chatting happily. After dinner, Aster helped Mother clean the dishes and then went to brush his teeth. He then ran to his room where Cosmo was already in bed, reading a book. Seeing his brother, Cosmo waved, Brother, come here. Look at this. Aster approached and sat next to his brother's bed. What is it? Look, brother, it's the Southern Cross, crux, Cosmo said, pointing to a picture in the book. Wow, you're right. I heard it's also used on the flags of some countries. Unfortunately, from where we are, it's impossible to see this constellation, Aster said. Without them realizing it, Grandfather had been standing at their door, listening to their conversation. Ahem, Grandfather cleared his throat and knocked on their door. My grandsons are very enthusiastic, huh? Are you ready to hear Grandfather's story for tonight? Aster and Cosmo nodded. Of course, Grandfather. Grandfather smiled, then took a seat near them. If so, I will start telling you more about the wonders of the universe. This afternoon, I was explaining about constellations and asterisms and star classifications, right? Yes, Grandfather, Cosmo said. Grandfather nodded and continued. Then, let's continue from there. Previously, when explaining star classifications, I mentioned white dwarfs and red dwarfs, but there is one more I missed. The brown dwarf. Yes, a brown dwarf is an object with a mass too low to sustain hydrogen fusion in its core but more massive than a giant gas planet. Their mass ranges from 13 to 80 times that of Jupiter. Brown dwarfs don't emit energy from nuclear fusion like regular stars, but from gravitational contraction and deuterium burning for the more massive ones. An example of a brown dwarf is Lumen 16, located in the Vela constellation. Oh, even with such a large mass? Aster said, surprised. Grandfather smiled and continued. Also, I previously explained star classification based on spectrum. Did you know that a star's color spectrum varies based on its surface temperature? So, a star's color reveals its temperature range. For example, red means a temperature below 3500 K, such as M-type stars. An example is Betelgeuse. Then, red-orange, meaning a temperature of about 3500 K, such as K-type stars. An example is Aldebaran. Next, yellow, meaning a temperature of about 6000 K, such as G-type stars. An example is the sun. Then there's white-yellow, meaning a temperature of about 7500 K, such as F-type stars. An example is Procyon. White, meaning a temperature of about 7500-10,000 K, such as A-type stars. An example is Sirius. Blue-white for stars with a temperature of about 10,000-30,000 K, such as B-type stars. An example is Rigel. Finally, blue, a temperature above 30,000 K, such as O-type stars. An example is Zeta Puppis. Isn't that fascinating? Wow, so that's how it is, Grandfather, Aster said, amazed. Grandfather nodded and continued. Also, every star essentially undergoes an evolutionary process in its lifetime. The evolution of a star depends on its mass. For low-mass stars less than 0.5 solar masses, in the formation stage, clouds of gas and dust collapse to form a protostar. Then, in the main sequence stage, the star undergoes hydrogen fusion in its core, generating energy. This star will then become a red dwarf, living very long, more than 100 billion years. Its death occurs when it becomes a white dwarf after shedding its outer layers without going through a red giant phase. Next, for intermediate mass stars, 0.5 to 8 solar masses, in the formation stage, clouds of gas and dust collapse to form a protostar. Then, in the main sequence stage, hydrogen fusion occurs in the core. This star will then evolve into a red giant after exhausting its hydrogen, where the star expands and starts burning helium. Eventually, the star will become a planetary nebula where the outer layers are shed, leaving behind a core that becomes a white dwarf. Lastly, for high-mass stars more than 8 solar masses. In the formation stage, clouds of gas and dust collapse to form a protostar. Then, in the main sequence stage, hydrogen fusion occurs in the core. This star will then evolve into a red supergiant, blue supergiant after exhausting its hydrogen, and starts burning helium and heavier elements. Then, after the core reaches iron, the star will undergo a supernova explosion. The remaining core becomes a neutron star or collapses into a black hole, depending on its mass. Yes, it might be as simple as that. Grandfather paused to drink some water. Wow, so stars are just like us, born, grow up, and then die. That's really interesting, Grandfather. Is there more, Grandfather? Aster asked. Grandfather nodded, then continued, certainly, but now let's switch from stars to planets. I recall that earlier when I explained about the inner and outer planets in the solar system, I didn't inform you about their eccentricities. Well, perhaps the numbers aren't too crucial to mention here, but what you need to know is that planets and other bodies don't orbit the sun in perfect circular paths as depicted in books, but rather in elliptical orbits with varying elongations. Therefore, we introduce another term, orbital eccentricity. Eccentricity E is a measure of how elliptical an orbit is. Its value ranges from 0 perfect circle to 1 parabola. For planets in the solar system, eccentricity is generally low, meaning their orbits are nearly circular. A value of E equals 0 means a perfectly circular orbit. A value of 0 less than E less than 1 means an elliptical orbit. A value of E equals 1 means a parabolic orbit, where the object will escape the solar system. A value of E greater than 1 means a hyperbolic orbit, where the object will also escape the solar system. This eccentricity affects the planet's distance from the sun during its orbit. A more elliptical orbit means a greater difference between perihelion, closest point to the sun, and aphelion, farthest point from the sun, influencing temperature variations and the length of seasons on that planet. So for now, this is the basic understanding you should have about eccentricity. Now, finally for tonight, I will tell you something that may be quite surprising. What is it, Grandpa? What is it? Asked Aster and Cosmo eagerly. Well, my grandchildren are indeed very enthusiastic. So what I want to tell you is that our universe is actually expanding. Perhaps I can illustrate this with a balloon, Grandfather said, then blew up a balloon. Afterward, he drew some dots with a marker on the surface of the balloon. All right, let me explain, Grandfather said. So, in 1929, an astronomer named Edwin Hubble made a significant discovery that showed the universe is expanding. This discovery was based on observations that distant galaxies are moving away from us at speeds proportional to their distances. This means the farther a galaxy is, the faster it is moving away. This phenomenon is known as Hubble's law. At that time, Edwin Hubble used a telescope at the Mount Wilson Observatory to observe the light spectrum from distant galaxies. He found that the spectral lines of these galaxies were shifting towards red redshift. Hubble interpreted this redshift as a sign that these galaxies were moving away from us. In other words, the universe is expanding. So, Aster, Cosmo, there are two terms you need to understand here, redshift and blue shift, which are phenomena caused by the Doppler effect on light. Redshift occurs when a celestial object moves away from the observer, causing the wavelength of its light to lengthen or shift towards the red end of the spectrum. In the context of the universe's expansion, redshift is used as evidence that galaxies are moving away from us. The greater the redshift, the faster the galaxy is moving away, indicating it is at a greater distance. Meanwhile, blue shift occurs when a celestial object moves towards the observer, causing the wavelength of its light to shorten or shift towards the blue end of the spectrum. Blue shift is less commonly observed in the context of the universe's expansion, but it can be seen in stars or galaxies moving towards us, such as Andromeda. Hubble's observations showed that the universe is not static but dynamic, continuously expanding. Look at these dots on the balloon while I keep inflating it. Grandfather continued to blow air into the balloon, making it larger. Do you see? The distance between these dots is increasing. These dots represent galaxies. Hubble formulated a linear relationship between the distance of galaxies and their velocities, Hubble's law. This law provides the basis for the Big Bang theory, which states that the universe began from a very dense and hot point around 13.8 billion years ago and has been expanding ever since. Redshift not only provides evidence of the universe's expansion but also allows scientists to measure cosmological distances and the age of the universe. By observing the redshift of distant galaxies, we can map out the three-dimensional universe and study its evolutionary history. I will tell you more about the Big Bang another time. Isn't this something unexpected? Wow, that's right. One more thing, finally for today. Perhaps I've mentioned before that stars appear to rotate in the sky because it's actually the Earth that rotates, and the stars themselves are stationary. But in reality, the stars in the sky aren't entirely static. Though this motion is very slow and almost imperceptible to the naked eye within the span of a human lifetime, stars do move through space at different speeds. So, there's what's known as proper motion, which is the movement of stars in the sky relative to the background of distant stars. Proper motion is measured in arcseconds per year. For example, Barnard's star has the largest known proper motion, about 10.3 arcseconds per year. Additionally, there's radial motion. Radial motion is the component of a star's velocity towards or away from Earth. It's measured using the Doppler effect, by examining the shift in the star's light spectrum, redshift or blue shift, as I explained earlier. Stars in our galaxy orbit the center of the Milky Way. Our Sun, for instance, moves at a speed of about 828,000 kilometers per hour in its orbit around the galactic center. Because stars are in motion, the patterns of constellations we know today will change over time. For example, the shape of the Orion constellation will change over thousands of years because its component stars have different proper motions. These changes in star positions can be observed on scales of thousands to millions of years. However, within a human lifespan, constellations appear almost fixed due to this slow movement. Yet some stars, like Arcturus, have high proper motion, moving about 2 arcseconds per year. In a few thousand years, its position in the Boötes constellation will change, explained Grandfather. Ah, is that so, Grandpa? Wow, this means the boundaries and shapes of the constellations we see now are different from before and will be different in the future, right? Wow, it seems there are many fascinating things we didn't know before, said Aster. That's right, and even now there are many mysteries left unanswered. Astronomers and scientists continue to search for answers to these mysteries. Therefore, if we have a sense of wonder and curiosity, let's not just leave it be. We should make real efforts to find the answers to what we seek. Though it's not always easy, at least that's what will bring progress for ourselves. Do you understand, Aster, Cosmo? Said Grandfather. We understand, Grandpa, said Aster and Cosmo. Alright then, for tonight let's keep the story short here. Cosmo still needs plenty of rest to fully recover. Well, good night, my grandchildren, said Grandfather. Good night, Grandpa. Thank you, Grandpa, for the story, said Aster and Cosmo. They soon lay down in their respective beds. That night, our two shepherd boys slept happily amidst dreams that took them on journeys among the awe-inspiring cosmos. Thus concludes today's episode of the Stellar Twin Voyagers. Wasn't it enjoyable? Would you like to hear more amazing tales from our young shepherds who write their stories among the stars? Therefore, stay with us on this program, and we'll meet again in the next episode. In short, I am Nova A239, delighted to have shared this story with you today. Until next time, let's continue to explore our dreams among the stars.